All right, today we're going to talk about reference angles. These reference angles are going to be able to put everything into the first quadrant. I told you when we learned about the unit circle that all we really need is the first quadrant, and that is 100% true. We just got to find a way to put all of our numbers in that first quadrant. All right, before we kick that off, let's go ahead and do the bell work. It says we're supposed to find the exact values of all of these degrees. So we have the sine of 30, sine of 150, sine of 210, and sine of 330. Well, the sine of 30 degrees, that is our very first tick mark. Sine always starts at 1, so we're at 1 over 2. Well, the sine of 150, if we look that up, is also 1 over 2. The sine of 210 is negative 1/2. And finally, the sine of 330 is negative 1/2. Now, it wasn't a coincidence that I picked all four of these values, and all four of them are either a positive or a negative 1/2. And that leads us to why we can use reference angles. Because the unit circle repeats in each quadrant, these 1/2s, these square root of 2 over 2's, and these square root of 3 over 2's, all we have to do is figure out which of these angles match up, and we just need, in fact, in these cases, for sine of 30, sine of 150, sine of 210, and sine of 330, all we really needed to know was the sine of 30 equals 1/2. And then we just had to remember that all students take calculus to figure out these negative signs. So once again, what reference angles are is basically taking 150 and reducing it down to 30, taking 210, reducing it down to 30, taking 330, and reducing it down to 30 degrees. So we can get right to that 1/2, and then we just got to worry about which quadrant we're in, and then we can put a positive or a negative based upon that. So let's jump right into it. All right, like I said, we're going to be working on reference angles. And what a reference angle is, so a reference angle is called theta prime. That's what we have going on here. It's called theta prime. It's just theta with a little dash above. All right, for any angle theta in standard position, there is a positive acute angle formed by the terminal side of theta and the x-axis. So we're finding the quickest way to get from that terminal side to the x-axis. So we're going straight down or straight up, as the case may need. So let's go ahead and see some examples. So we're supposed to name the reference angle for 30 degrees, 150, 210, and 330. Well, if we look at the 30-degree angle, the quickest way to the x-axis is actually straight down. So the reference angle to a 30-degree angle is, in fact, 30 degrees. In fact, to be a reference angle, we're looking for an angle between 0 and 90 degrees. That's all we're really looking for, is an angle between 0 and 90 degrees. If you did that, you probably found your reference angle. All right, now let's look at 150. Now, the quickest way to the x-axis is not going all the way back that way. That's 150 degrees. The quickest way to the x-axis is actually just dropping straight down. And if we look at the fact that this is 180 degrees, that red angle right there is actually 30 degrees. 150 plus 30 equals our 180. So the reference angle for 150 is 30 degrees. How we came up with that mathematically is we actually took 180 minus the 150 to give us that 30 degrees. All right, for 210, the quickest way to the x-axis is actually up. And once again, I'm thinking about this 180 degrees. Well, 210 minus 30 equals that 80 degrees. So this is, again, a reference angle of 30 degrees. So we have a reference angle of 30 degrees. In this case, though, we took our angle, 210, and we subtracted 180 from that to give us our 30 degrees. All right, finally, we have 330 degrees. Well, the quickest way to the x-axis is straight up. Now, 330, we know that this is 360 degrees. So to get from 330 to 360, we are going to add 30 degrees. So once again, our reference angle is 30 degrees. In this case, we took 360 and we subtracted 330 degrees. So a reference angle is that angle between 0 and 90 degrees, and it's the quickest way to get to the x-axis. Let's look at some more examples. So this one says name the reference angle for each. Well, the reference angles are all down here. So if we look at 30 degrees, we're looking at this one. Our reference angle is just 30 degrees. For 135, our reference angle is going to be 45 degrees because 135 plus 45 equals that 180. For 240, our reference angle is 60. For 330, our reference angle is 30 again. For negative 210, now I want to focus on these. So if we have a negative, we can do the same thing. So if I have negative 210, the quickest way to the x-axis is that 30 degrees. More likely, I mean, if they give you degrees, it's pretty easy to kind of picture how far it went around and then looking for your reference angle. If they give you radians, you might be smart to add 2 pi to it until it's positive so that we can deal with the positive. Sometimes it's a lot easier dealing with positive angles than negative angles. So although, yes, this works with negative degrees, more than likely I'd probably add 2 pi or 360 to it to put it in a positive spin, and it makes it a little easier to kind of see. You follow that pattern of knowing exactly what quadrant you're in and where you need to go from that. Once we go negative, sometimes people struggle to find out which quadrant I'm in and then what I'm supposed to do. All right, the huge thing we need to pay attention to is what quadrant angles are in. If you are in quadrant 2, so let's go back here. Quadrant 2 is at 150 degrees. Note we did 180 minus 150. That's always going to work. Our reference angle is always going to be either 180 or pi minus the degrees or the radians. So if you're in quadrant 2, you do 180 minus the angle. If you're in quadrant 3, on the other hand, which is this one, you're going to take the angle and subtract the 180 or the pi, depending on if you're radians or degrees. I'm just going to remember this 180 because I can figure out pi from there because 180 equals pi. So I'm really focusing on that's our angle minus 180. Finally, if we get to our 4th quadrant, we're just going to do 360 minus the angle, which is also 2 pi minus the angle. Now, I'm going to preface this lesson, right kind of in the middle before we get to our examples, with the fact that for students to be really successful in this class, this is the easiest way to work the unit circle, is to remember reference angles. So although we won't do a ton of work with it, we'll basically focus on it today. I will be using it in class. I will be telling you how to use it on assignments, and it makes your life so much easier just to know the first quadrant than to have to know the whole unit circle every time I ask for, 240 degrees. Because when I ask for 240 degrees, all I want you to be able to do is think, okay, 240 degrees, we are going to be in the 3rd quadrant, so I'm just going to take 240 minus 80 equals 60 degrees. Oh, 60 degrees, I know what value that is. All right, let's go through some examples. So it says sketch the reference angle of theta prime. Remember, theta prime is your reference angle. Well, first let's sketch 120 degrees to figure out where we are actually going. Well, 120 degrees. 120 degrees, we all started at our initial side. 120 degrees is somewhere in quadrant 2. It's bigger than 90. It's less than 180. So this right here is our 120 degrees. Well, our reference angle is going to be the rest of that to get us to 180, which is going to be 60 degrees. So my reference angle is that little black angle right there, and we'll put a little 60 degrees by it. Would I draw these angles every single time? No, I would not. Instead, what I would recognize is that, 120, that's in our quadrant 2. And then I would just go, okay, in quadrant 2 we have 180 minus 120. That just equals our 60 degrees. So that means my reference angle is 60 degrees. I would just do that math. I do want to point something out real quick. Let's say you forget. You're on the test and you're like, I forget if I have to add, or if I need to subtract the angle from 180 or subtract 180 from the angle. Well, if you ever mess it up, so I'm going to go ahead and mess it up. I'm going to do 120 minus 180 degrees, which is come out to negative 60 degrees. This still works as long as you realize your reference angle is always going to be positive. So in effect, we're kind of thinking like take the absolute value of that. So our reference angle would still be 60 degrees. I would just take that negative off and make it regular old 60 degrees. So if you ever do it the wrong way and you come up with a negative, just go, oh, I did the wrong one, but I just got to make it positive, and that is my reference angle. All All right, 7 pi over 6. Later in this lesson, we'll talk about how I know what quadrant it is, but there's a very easy way to tell what quadrant is that it's in. And that is because if you look at the 7 and the 6, 7 is exactly 1 bigger than 6. Whenever your numerator is 1 bigger than your numerator for radians, you're going to immediately know it's in quadrant 3. So you don't even write all that stuff down. All you're really looking for is your numerator and your denominator. Once again, if your numerator is 1 bigger than your denominator, you are in quadrant 3. So let's go ahead and draw that. So we're looking at an angle in quadrant 3. I don't even care where it is in quadrant 3. I just know it's in quadrant 3. And so our angle is that big one right there. That is our 7 pi over 6. Now, the quickest way to our x-axis is to come up like that. Well, all we're really doing is we're subtracting away pi, or 180 degrees. Once again, if you look up, quadrant 3 is either, our two things are, if you're quadrant 2 or quadrant 3, is either you're subtracting pi or you're subtracting the angle from pi. It's always something with pi. In this case, it is taking 7 pi over 6 and subtracting pi. If you did it the wrong order, you just make whatever you get positive, and you'll have the correct answer. Well, to subtract pi, we need to actually subtract 6 pi over 6, which is just going to equal pi over 6. So our reference angle is pi over 6. All right, let's do a couple more. All right, now we have negative 7 pi over 4. Negative 7 pi over 4. Like I said, you can kind of sketch everything backwards, but I'm more likely going to just find a reference or the coterminal angle to it. So I'm going to find the coterminal angle first. Whenever I have a negative, I'm going to find my coterminal positive angle. So I'm going to find that positive coterminal angle. Positive angle. If you're really good about radians and you just know where that is or what quadrant it is, more power to you. Do it backwards. But for right now, I'm going to focus on just making it positive. And that's negative 7 pi over 4. And I'm just going to add 2 pi over and over and over until it's positive. In this case, we just have to add it once, because then we'll have negative 7 pi over 4. Plus, that'll be 8 pi over 4, which is going to equal pi over 4. Well, that's nice. That's really nice. Since our coterminal angle is pi over 4, we can go ahead and sketch that. Well, pi over 4 is in quadrant 1. The nice little thing that tells you what quadrant that is in, if you look at your numerator, if that's a 1, you are in quadrant 1. So we're in quadrant 1. Well, quadrant 1, the reference angle is the exact same thing as its angle. So that means the reference angle is pi over 4, but it also means, the coterminal angle is pi over 4, but that also means the reference angle is also pi over 4. So our answer is going to be pi over 4. That's why I like to put that positive spin on it. I add that 2 pi to it because sometimes that already is your coterminal angle. So we find our coterminal angle, and it just happens to also be our reference angle. So if we were picturing this, negative 7 pi over 4 would actually be that angle there, with the reference angle of pi over 4. All right, our last one right here on this sheet before we get to some trig information about it is 690 degrees. That is too big. That is too big for us to be able to put on the unit circle. So once again, we're going to find a coterminal angle. And we find coterminal angles of a too big angle by subtracting either 2 pi or 360 from it over and over and over again. So in this case, we're going to take 690 and we're going to subtract 360 from that. Well, that's just going to equal 330 degrees. That is our coterminal angle. And I know to stop because it's between 0 and 360. If it was not between 0 and 360, I'd have to subtract 360 again. So 330 degrees, that's in quadrant 4. That's in my quadrant 4. So what that tells me I need to do, I need to take 360 and subtract away the angle. which is going to equal 30 degrees. So in short, our reference angle is just 30 degrees. Once again, if you forget which order to do this in, if you do 330 minus 360, you just come up with negative 30 and you just make it positive. The only time you did something wrong is if you come up with something that's not between 0 and 90, then you probably did something wrong. For instance, if I would take 330 and subtract 180, I'd be left with 150, which isn't between 0 and 130, so that means I have to do 180 again. All right, so it does say to sketch it. So we can sketch an angle in the fourth quadrant, I should say. The actual angle is this guy that goes like this. My reference angle is this angle right here, which is 30 degrees. All right, so reference angles. It's just the quickest way, basically, to get to, in quadrant 2, we're looking for something that adds to give us 180. In quadrant 3, we're looking for something that subtracts to give us 180. And then we're looking at quadrant 4 is taking 360 and subtracting our angle to get the closest number between 0 and 90 degrees. How does that help us with our trig? Oh, if we looked at our very first bell work, we noted that 30 degrees, 150, 210, and 330 all have the same reference angle of 330 degrees. From the bell work, if you take the sine of each of these degrees, your answer will either be 1/2 or negative 1/2. Why is this important? Well, if you know the reference angle and the quadrant you are in, there's no need to actually find the exact values. You use your reference angle. Remember, we will use all students take calculus to determine positive or negative. All right, we're supposed to find the sine and cosine using reference angle for 120 degrees. Once again, 120 degrees is in quadrant 2. So that is our actual angle that I'm looking for. So let's use our all students take calculus real quick. So all students, so we are in our students section, so that means our sine is positive and our cosine is negative. Once again, this quadrant is our all. Then we got our students take calculus. So for students, sine is positive, cosine is negative. Now all we have to do is figure out what the reference angle is. Once again, 120 is in quadrant 2. Quadrant 2 tells us to do 180 minus our angle, which is going to equal 60 degrees. So the sine of 120 is going to equal the sine of 60 degrees. Now 60 degrees is that third tick mark. So for sine, the nice thing is that third angle is going to be our square root of 3 over 2. So that's our sine value. Now cosine of 120. What I want to note is the cosine of 120 is positive, or I'm sorry, of 60 is positive. The cosine of 120 needs to be negative. So what you need to do is, as soon as you know cosine is negative, we have to remember to attach a negative sign out front of it. So the cosine of 120 equals the negative cosine of 60 degrees, which is negative 1/2. And now I just need to know quadrant 1. All right, 7 pi over 6. I already taught you that trick, the first trick that we're going to talk about. And we look at our numerator and our denominator. If our numerator is exactly 1 more than our denominator, you are automatically in quadrant 3. For quadrant 3, we have all students take. So if we are in quadrant 3, somewhere over here, all students take. That means tangent is positive, everything else is negative. So our sine is negative, our cosine is negative. So whatever answer we get with our reference angle, we are just going to make it negative. All right, so first let's find our reference angle. If you're in quadrant 3, you are going to take 7 pi over 6, and you're basically subtracting 180, but in radians you are subtracting pi, which is 7 pi over 6 minus 12 pi over 6. Oh, hang on. I did 2 pi. Back. All right, we're actually just subtracting regular pi. So we're going to do 6 pi over 6, which is going to equal pi over 6. So remember, the only time we're subtracting 2 pi or 360 is if we're finding coterminal angles. which has the same results. Our reference angles, we're basically going to subtract 180 or pi from this one. So our reference angle is pi over 6. So our reference angle equals pi over 6. So that means our sine of 7 pi over 6 is going to be the exact same thing as a negative sine of pi over 6. Well, pi over 6 is actually your first tick mark. For sine, our first tick mark is 1/2, so it's going to be negative 1/2. Our sine equals a negative 1/2. Our cosine of 7 pi over 6 is going to equal negative, once again, because we know cosine is negative in quadrant 3, cosine of pi over 6, which is going to equal, well, if sine is 1/2, that means cosine is square root of 3 over 2. They match up, and it's going to be negative. All right, so that's how we're going to apply our reference angles to using sine, cosine, without having to go to quadrant 2, 3, or 4. We can know just the quadrant 1 values, and we can successfully do almost any angle from there. All right, a little cheat sheet. All right, if you were in quadrant 1, we have theta equals just your reference angle. If you are in quadrant 2, you're going to do 180 minus your angle. For radians, you're going to do pi minus your angle. Quadrant 3, we're going to do our angle minus 180, or we're going to do our angle minus pi. Finally, if you're in quadrant 4, you're going to do 360 minus your angle, or not 360, but 2 pi minus your angle. Remember, if you ever flip up your subtraction, you flip something, just make sure you make it positive. So in other words, if I'm in quadrant 2 and I accidentally do my angle minus 180, I'm just going to come up with a negative angle, make it positive, and you are good to go. All right, this other cheat sheet is I'm going to talk about radians. How do I know what quadrant radians are in without having to draw out the whole thing and figure out if it's between something? Well, it's really easy with these key angles that we use. I already talked about one of them, and that is if your numerator is 1, you are in the first quadrant. So our numerator is 1. An example of that is going to be our pi over 4. Our numerator is 1, so we are in the first quadrant. So pi over 6, pi over 4, pi over 3. If that is 1, we are in the first quadrant. The only time we're not quite in the first quadrant is if it's pi over 2. But you should know pi over 2 is 90 degrees. So typically speaking, if your numerator is 1, you are in the first quadrant. Let's move on to the second quadrant. The second quadrant is if your numerator is 1 smaller than your denominator. So our numerator is 1 less than the denominator. So my example of that is 3 pi over 4. We look at our numerator, it's 1 less, exactly 1 less than the denominator. We are in quadrant 2. For quadrant 3, if your numerator is 1 bigger, your numerator is 1 bigger. Numerator is 1 bigger than our denominator. So an example of that might be 5 pi over 4. Note our numerator is exactly 1 bigger than our denominator. All right, quadrant 4, we're just going to go, that's something else. So I'm talking about, an example would be 7 pi over 4. Our numerator isn't 1. It's not exactly 1 more or 1 less. It's something else. We are in quadrant 4. And this will work for almost any angle, especially the ones we do in this class. So once again, that can make your reference angle so much easier. Know what's in quadrant 1, quadrant 2, quadrant 3, quadrant 4, and you're going to make your life so much easier. All right, that's reference angles. Let's get started on the homework.